This video aims to provide the viewer with an insight on the CODECO framework operation through the presented user stories. We will go over the major steps and processes from the CODECO framework installation to the deployment of an app by the user. In our scenario, the user wants to deploy an application consisting of multiple microservices, that is, multiple Docker images across the far edge to the cloud, and will use the CODECO framework to manage and optimize this deployment. The first user story is dedicated to the installation of the CODECO framework. The user has already created a cluster according to an initial estimation of the application's needs. In this, we quickly set up a kind cluster with 3 nodes, 1 master and 2 worker nodes, and installed the CNI of our choice. The user then downloads CODECO from the CODECO Eclipse GitLab and follows the instructions to set up ACM. ACM, or Automated Cluster Management, is the component through which the user interacts with CODECO. Our first step here is to fetch the ACM repository and then follow the installation steps provided. This will automatically trigger the installation of every other CODECO component, namely NetMA, SWM, PDLC, and MDM, and of course, the creation of the complete Kubernetes setup, including monitoring tools like Prometheus.
After the cluster is created and all components and subcomponents are up and running, NetMA creates the NetMA topology CR for SWM and PDLC to use in their processes. In this CR, NetMA exposes the network architecture and underlay metrics, describing the nodes of the cluster, as well as the network links between the nodes. In this phase, CODECO is fully installed and the user is ready to deploy an application. To define a CODECO application, the user is provided with a CODECO Application Model CRD. In this file, the user defines aspects such as desired quality of service, quality of experience, or other desired performance levels for CODECO and application requirements like CPU or bandwidth. The deployment of such a file brings us to user story 2. Deployment of a CODECO application. After application requirements are exposed, the operation of all CODECO components is triggered. Immediately, SWM makes an initial application workload placement based on metrics available in CODECO. Specifically, ACM provides computational metrics, NetMA provides network metrics, and SWM assigns each application pod to a specific node of the cluster. This initial scheduling will be updated later based on node recommendations by PDLC. In this stage, we can confirm that the demo application is up and running. We can overview this initial workload placement in the assignment plan CR, where each application pod is assigned to a node. After the application is deployed by SWM, NetMA triggers the definition of the network overlay. In the NetMA topologies CR, the overlay metrics section is now filled with all the necessary metrics and details of the network links. After activation, PDLC regularly obtains a series of metrics from the other components. MDM provides crucial application metadata like freshness. NetMA is responsible for all necessary network metrics, and ACM passes any user aspects and application constraints. PDLC performs a multi-level objective estimation based on the user-selected target profiles and stores the output on a PDLC CRD, making it available to ACM, which may trigger adjustments to the initial setup process. PDLC also writes the computed node recommendations on an SWM CR, which SWM then takes into consideration for the application deployment process.
The node recommendations are not present in current CODECO installations and are still a work in progress due to the increased complexity of real-time component communication through CRDs. One can observe here the appropriate structure of node recommendations in the respective SWM CR from a PDLC installation in an isolated environment. Here, PDLC recommends the optimal node for every application pod to be deployed.
The function of PDLC, which we consider to be the brain of the CODECO framework, is explained in detail in a separate video. In this phase, SWM takes into consideration the node recommendations provided by PDLC, and in a reset of SWM, a new workload placement is executed, according to the node recommendations that PDLC previously provided. In parallel, 3 components start monitoring different metrics. NetMA captures network metrics at node, link, and path level, and exposes this information via specific CRs that are accessible to all components and used by PDLC and ACM. Similarly, MDM captures data aspects like data compliance, generates a knowledge graph, and provides the output as well to other components via the MDM API. ACM captures user preferences and eventually behavior, which may be useful for adapting the overall Kubernetes infrastructure at a later stage. Note also that the exchange of important metrics between components is assisted by Prometheus in interconnection with the ACM component. Once the setup is complete, CODECO enters the cluster management phase, application runtime support. During this phase, the proposed application has been set up and is running on several Docker containers, which are distributed across one or more Kubernetes pods per worker node. PDLC periodically checks the data monitored by MDM, NetMA, and ACM. Furthermore, PDLC gets information on the performed assignment from SWM regarding the placement of the application workload. Based on this, PDLC periodically evaluates the proposed system performance targets like greenness or service latency provided by the user during application setup and provides a cost combination per infrastructure element via a CR. If there is a need for cross-layer redistribution of the application workload, this step triggers a request from ACM to all CODECO components.
The node recommendations computed by PDLC are periodically provided via a specific CR to SWM. Hence, if rescheduling occurs, the respective SWM CR assignment plan is accessible to PDLC. At the current stage of deployment, it is highlighted that the rescheduling process in CODECO is not yet implemented in SWM. This feature is mentioned in the list of SWM code open issues and will be completed until month 30 of the project.
Let's summarize. To install the CODECO framework, the user first installs ACM, which in turn automatically installs MDM, PDLC, SWM, and NetMA. Necessary metrics are exchanged primarily using Kubernetes CRs. The user then deploys a CODECO application through by deploying a CODECO application model CR, which triggers all other components. Subsequently, SWM makes an initial application placement, and after PDLC starts collecting data from the other components. When sufficient data is collected, the internal AI processes of PDLC, like GNNs and reinforcement learning, produce some node recommendations. Afterwards, SWM uses these node recommendations to make an optimal workload placement of the CODECO application's pods. This loop of metrics collection, node recommendations, and workload rescheduling continues indefinitely to ensure the desired performance, or until the user modifies the requirements through ACM.